bucka. Ha. You know the deal.
When dealing with sets of data, pieces of information where there's some mathematical relationship that's collected, gathered, whether it's the temperature during the day or how many people like different TV shows. These are terms that often come up when we're talking about data management or statistics. Mean, median, and mode. And that's what we're going to talk about next. And the first one we're going to look at here is mean. And the first question you're probably going to want to ask yourself is, well, what is mean? Another word for mean that's more commonly used is the average. And in a set of data, in a set of numbers, so if you have several numbers in front of you, the mean or the average is the mathematical middle or center of all those values. So, for example, let's say we have two numbers, 80 and 100. When we're talking about the mean or the average of those two numbers, we're talking about what's in the middle of those two numbers. And what is in the middle of those two numbers, right in the center, mathematically is 90. Because between 80 and 100, there's 20 values. And so to get halfway from 80 to 100, the halfway point would be 90. So 90 is considered the mean of 80 and 100. So when you ask yourself the question, what is the mean of a set of numbers, what you're really asking yourself is, what is the middle of those numbers? Well, when we're looking for the middle of 80 and 100, it's quite simple to see what's in the middle. It's a simple example because it's very easy to think about what's right in between 80 and 100, and that is 90. But there are cases where you have two numbers that are maybe very far apart and you want to know what the middle is, or if you have more than two numbers and you want to know what the middle of all of those numbers are. It can get a little bit more complicated than this. So we have to look for a way to mathematically find the mean using the two numbers. Well, one way that I discussed is you could see how many spaces are between the two numbers. 80 and 100, there's 20 spaces, so if we cut that in half, it's 10. But again, if we have two numbers that are really far apart, doing all of that math is a little bit of time consuming. Or if we have more than two numbers, it can be hard to wrap our heads around exactly what the middle is sometimes. Another way to calculate the middle is if we add the two numbers together. So if we take 80 and add it to 100, well, that tells us the total of these two values. And since there are two values, to figure out what's the middle, we divide it by how many values there are. And in this case, there are two values. We divide it by 2. And that gives us the mathematical middle. So you can see the middle of 80 and 100 is obviously 90, but mathematically we can figure that out by adding those two values together and dividing by how many values are there. So here's another example where I have this time 3 numbers, and but again I want to find what the mean is, what the middle of these 3 values are. And here, looking at these 3 values, I put them from smallest to biggest on purpose. And if we have 80, 100, and 120, the middle of all of those values is 100. It's exactly in the middle between 80 and 120. So I use these values on purpose. Let's see if our last method works here, where we take the 3 values and add them together. And this time, since I have 1, 2, 3 values in my set of values, to get the middle of those values, I'm going to divide by 3. And we can see the middle is 100. So calculating the average by adding the values together and then dividing by how many there are does give us the exact mathematical middle. So let's look at calculating the mean with now a slightly more complicated set of values. So if I go to look to see what's in the middle here, I can't see what's in the middle, and I can't see what's in the middle for a couple of reasons, because there's 4 values, so there's not one value that's right in the middle, and these values are quite wide ranging. We have 1, 5, 6, and 20. But again, if I want to know the mathematical middle or average of these values, we add the 4 values together, and then we divide by how many are there. So when we add those 4 together, we get 32. And since there are 1, 2, 3, 4 values here, we're going to divide that by 4 to figure out what the mathematical middle is here. And as it turns out, the mathematical middle is 8. Now, if we look back at this set of values here, and again, I've ordered them from smallest to biggest on purpose. If you look at this and you say, well, how can 8 be in the middle of these values? What we look when we analyze these numbers here is we have a few numbers that are pretty small, but then one number that is very large. And that one number that is very large is sort of pulling the middle towards a larger number. And it's also important to note that 8 is it's not actually one of the values here, but it is the mathematical center of all of those values. Just like for the first example that I used where we had 80 and 100, the middle of 80 and 100 is 90. 90 was not one of those set of values, and neither is 8 here. But mathematically, 8 is the very middle of 1, 5, 6, and 20. Next, let's take a look at a practical example where we're using a real-life situation where we have to calculate the mean. So suppose over the course of 1 week, these were the daily highest temperatures in Toronto. And we want to know what the average or the mean temperature was here. Well, as we've seen with a couple of these examples, to calculate the average, what we're going to do here is we're going to initially add all of these values together. We don't have to put them from smallest to highest when we're calculating the mean. It's not necessary. We can if we want to, but really we just need to simply add all of the values together. One thing that I like to do just to make sure I get them all is kind of cross them out as I add it to my math sentence. Now, it is important to note here I did include a negative, so there are integers involved in this question. But we are still adding that temperature. Since that temperature was -2, we have to add a -2. So I encourage you to pause the video and see if you can get the answer to this addition question with that negative there. And when I add those values, I get 44. And again, just like with the previous ones here, we have to now, to find the middle, we have to divide this by how many values there are here. There's 7 values here because we got the daily highest temperature for each day of the week. When we go ahead and use our calculator now to divide that, you get a pretty long decimal. I'm going to round that to 6.29. So what does that mean? Well, that means for this week, when we had these 7 daily high temperatures in Toronto, the average or middle temperature was just over 6 degrees. And that looks about right for this set of values. I mean, we had one really high one here, which was 12, which was pulling the average up quite a bit, but then we had this really low -2, which pulled it down. In the middle, the mathematical middle of all of these values is 6.29, and we get that by adding them all together and dividing by how many are there. So here's another practical application of calculating the average or the mean. So suppose over the course of a term you received the following marks out of 10 on each of your quizzes. And it's important to note here that each quiz was out of 10, so it was always out of the same number of marks. And the question is, well, what is your average or your mean mark? Well, as we've seen with a couple of examples now, to calculate the mathematical middle, one way to do it that always works is to add up all of the values that are there and divide it by how many values there are. So one important thing to note here is, you probably noticed this already, there is one mark of 0 here. So suppose you had been away maybe for a couple of weeks and you've missed a lesson, or maybe you weren't feeling well that day. Something happened there where you got a significantly lower mark than the rest of the marks. But because it was one of the marks, we do have to include it here in the values that I've added together here. So when we go ahead and add those values together, we get 50, and here again we have 7 values. And when we go ahead and use our calculator to do that, we get 7.14. So on the decimal goes on. If I round to the nearest whole number here, that's a 7. So if we were calculating your average or your mean mark of all of these marks, you would get a 7. Now, if you look back at these marks, if these were your marks on quizzes throughout the term, you did pretty well most of the time. I mean, other than the 0. I mean, the 0, that's not doing very well. But other than the 0, your lowest mark was a 7, and you got a 7 a couple of times, but you also got an 8, a 9 a couple of times, and perfect once. So I would say that to say that 7 is your average mark, or if I was your teacher to say, well, 7 is an indication of how you do overall, it's not really a fair assessment in this case. Although mathematically 7, or about 7.14, is the mathematical center of all of these values, I would say that as a teacher who's evaluating a student, I wouldn't say that's a fair way to say this is the center of these values. So in this case, I might use a different method to measure the middle value. And that's what we're going to talk about next, which is the median. So to explore the median, we're actually going to look at the same example here. So suppose you received the following marks over the course of a term, but instead of calculating your average or your mathematical middle by adding them all together and dividing by how many are there, what we're going to look for here is what's called the median of this set of values. So the question you're probably going to ask yourself is, well, what is the median? And the median is can be described as a given middle value of a set of values. So I'm going to show you what I mean by that here. When you're trying to find the median, the first thing you do have to do is put the values in order from smallest to biggest. And here's where it's particularly important to make sure you don't miss any. So we're starting with the smallest. That's 0. So that's our smallest value. Well, our next smallest value here is 1 of the 7s. We do have to include all of the values that we're given. So 7 is also another value, and it's the next biggest. Continuing to get bigger here, the next biggest value is our 8. And then we have 1 of our 9s. Another 9, and finally a 10. So now that we have the values in order from smallest to biggest, we can see that altogether there are 7 values. So the absolute middle value that's given is here. It's 8. It's right in the middle because there's 3 on this side and there's 3 on this side. So that 8 is right in the middle. So the median here, in this case, is the 8. I mean, that 0 did have an effect on your mark, but it didn't bring it down as much. So there's one example of where we might use the median to indicate what's in the middle rather than the mean. And again, the median is usually a given value, and we find the median by putting the values from smallest to biggest, and then seeing what number is in the center. Well, the natural question you might ask is, if the mean is the absolute mathematical middle of all of a set of values, why would you ever use the median? Why wouldn't you just always use the mean? Well, as we saw with that last example, getting that 1 mark of 0 brought your mark down quite a bit. It pulled it down, and it wasn't really a fair representation. We're going to look at another example like that involving real estate prices. So suppose over the course of a week in Toronto, we had 9 houses sell. Suppose these were the prices that they sold for. Well, to calculate the mean here, to calculate the average of these 9 prices, we would have to add them all together and divide by how many there are. So go ahead and give that a shot. Add these 9 values together and then divide by how many there are, and pause the video and see what you get. And I'm going to do the same thing, and hopefully we get the same answer. So when I add those 9 values up, I get 7,625,000. Hopefully that's what everybody got as well. If I made a mistake, please let me know in the comments. And to calculate the average here, we have to divide by how many there are. In this case, there's 9, so we'll go ahead and use our calculator and divide that big number by 9. And when I do that, I get $847,222.22 rounded to the nearest cent. So this is the mathematical middle of these 9 values. But if I'm a real estate agent and I want to have a general idea of the average or the middle price or about what houses are selling for in Toronto, if I were to calculate the average here and look at this number, this is about 850,000. I'm thinking houses are selling for really a lot of money. But if we look at this set of values, the only time we see over or even around 850,000 is this one value here. Every other value is less than that, except for this one. And this one is a really big one. So this is some mansion that's sold somewhere in Toronto for a lot of money, over $3 million. And the thing here is, when we're calculating the mathematical middle of all these values, this is the mathematical middle of all these values, but this big number here, it's pulling that average up, and it's not really giving a fair indication as to what the overall trend is. And that's when we would use the median. Just like with the last example, that one mark of 0 brought your mark down to a 7, where it's not really a fair evaluation. Because you had that one value that was quite a bit smaller. In this case, we have one value that's a lot bigger than the rest of the values. And this is where we tend to use the median. And it doesn't necessarily just have to be one value. But if we've got, let's say if you're looking at the value, the prices of houses in Toronto over a whole year, if you've just got a few houses that are this big that in terms of a price, or even in the tens of millions of dollars, they're going to bring the overall average way up. So if we have a few values that are much, much higher, or a few values that are much, much lower than most of the other values, that's when we use the median. And let's do that here. So I'm going to leave our calculation for mean up there while we're working on the median here. And so as we saw with the last example, when we're trying to figure out what the median is, the first thing we have to do is rearrange these values so that they're from smallest to biggest. So I'm going to go ahead and do that now. Okay, so now that I've rearranged those from smallest to biggest, hopefully you can still see those numbers. You can see there are still 9 values here. So the middle value here is the 5th value, because it's the middle because there's 4 on this side and there's 4 on this side. So the middle value of the given set of values here is 550,000. And you can see that's quite a bit less than our mathematical middle, our average, which was about 850,000. And that's because, again, this 3 million was really pulling the mathematical middle up. Whereas if I'm a real estate agent and I want to know kind of the middle price, where about things are selling for, this is a better indication here than the median, because again we had this one value that was much bigger than all of the other values. And it's important to note that it doesn't necessarily just have to be one value that's bringing up the average. If you look at the example of selling houses again, if in Toronto thousands of houses a year sell, if you have a few houses that are much, much higher, like in the tens of millions of dollars, calculating the mean isn't really a fair way to indicate what the middle is, because those houses are going to pull that average up. And that's why for real estate prices in Toronto anyway, they actually do use the median as an indication of what's in the middle. And with the median, we put the values in order from smallest to biggest, and we look for what value that's given is right in the middle. Let's look at one more example of calculating the median, and this time again I'm going to use the example of quiz marks, where suppose you had 4 quiz marks and you wanted to know what the middle mark was, and you looked at these marks and said, look, it's not fair to calculate the mean here. It's not fair to calculate the average because this 0 is going to bring your mark significantly down. So what you ask is, can you use the median instead? And I would use the median here because that 0 is a lot less than the other 3 marks that you got. The problem here when trying to find the median is we have an even number of values. So if I look to the center here, it's here in between this 8 and this 10. So I don't actually have a given middle value. And in this case, if we're not given a value that's right in the middle, or if we have an even number of values, we have to take these 2 numbers that are in the middle and calculate the mean of those 2 values. So we would add them together and divide by how many there are. In this case, we're only adding these 2 together, so we're only dividing by 2. And so your median mark here would be 9. Whereas if we calculated the mean here, to calculate the mean of this set of values, we would have to add them all together. Now calculate the average. I have to divide by 4 because there are 4 marks here. And you would find that your mean is 7. And once again, if I look at these quiz marks and I want to give sort of an indication of where a student's at, but I do want to count that 0, I would say that the median is a more fair way to indicate what's in the middle. And you can see here the median is quite a bit higher than the mean. Because there was an even number of values here, though, we had to take the 2 values that were in the middle, and I did put them in order from smallest to biggest. Those 2 values in the middle were 8 and 10. We have to calculate the mean of those 2 values. The last thing we're going to talk about is mode when we're talking about a set of values. And mode is another way to sort of indicate where the values are at. Mode is the value or values that appears the most in a set of values. I'm just going to talk about this very briefly. It is possible to have no mode. So for example, if all the values appear the same number of times. So if this was our set of values, well, each number appears twice. Each number appears the same number of times. So there is no mode here because they all appear the same number of times. It's also possible to have more than one mode. So if this was our set of values, then we can see here that some of the values do repeat, but the 2 values that repeat the most are the 1s and the 12s. They each repeat 3 times. So in this case, the mode is 1 and 12 because they appear the most in this list. So to finish off our lesson on mean, median, and mode, I'm going to ask you to do a couple of things here. For question number 1, just for each one of those 3 questions there, calculate the mean, the median, and the mode for each one of those sets of values. Question number 2, what I'm going to ask you to do is calculate the average number of goals this goalie allows in each game. So there we have the results of how many goals the goalie allowed for each game. So first calculate the mean and then get the median. And then answer the question, which do you think is a more fair indication of how well the goalie is doing and why? If you're able to do that, congratulations, you now have a firm understanding of mean, median, and mode.